everyone, welcome to Pepcoding. So the question which we will discuss today is called rank transform of a matrix. So it is a very important question. So first let us understand the question and then we will head over to its solution. Okay. So basically what is happening is that you have been given an array which is of m by n dimensions, and we have to return a new matrix which is by the name of answer, where answer of row comma column is the rank of the matrix row and column. Okay, so first understand what rank is. Rank is an integer that represents how large an element is compared to other elements. It is calculated using the following rules. First thing you need to understand is that if over here I have an array of 3 by 3, okay, so for this position I will check its entire row and its entire column, that is all the neighboring elements, and I will check according to all of these positions as compared to all of my neighbors, how large is this element. Okay, and that will be the rank. So for example, if I'm working with an array of 2 by 2, so I have -1, 2, 2 and 3. So when I'm checking for -1 is less than 2 also, and -1 is less than this 2 also. So the rank of this will be 1. Why? Because it is the smallest. And so on we will move. So first let us understand the rules in which we have to work, and then we will use these examples to understand it better. Okay. So we are saying that the rank is an integer which is starting from 1. Okay. So rank starts from 1. If two elements P and Q are in the same row or column, then if P is less than Q, then rank of P should be less than rank of Q. If P is equal to Q, then rank of P should be equal to rank of Q, but only in the condition that they are in the same row or column. And if P is greater than Q, then rank of P should be greater than rank of Q. Okay, and the rank should be as small as possible. That means that if you are in an array and you have, for example, let's say I have 1, 2, 2 and 47. Okay, so the rank of 1 will be 1 only. The rank of 2, it should be greater than this because 1 is smaller than 2. So the rank of 1 should be smaller than 2 as well. So the rank of 2 will be 2. Then again we have this 2. So for it also the rank will be 2. Now when we come to 47, right, we are not going to take any random number as our rank since it is the largest element. See, the only thing you need to do is 1 greater. Okay, so it is greater than this 2 also, it is greater than this 2 also. So its rank should be greater than these, right? So the rank of this is 2, the rank of this 2 is also 2. So the rank of 47 should be greater than 2, which is 3. So you will just have to write 3 over here. That is, the rank should be as small as possible. Okay. All right. It is guaranteed that the answer is unique under the given rules. All right. So first let us understand with this example. Over here I have a matrix, right? So I have the matrix 1, 2, 3 and 4. And this is the matrix it will be transformed to. So this is my rank matrix. See how we got this answer. So basically over here I have 1. I will compare 1 with 2. I will compare 1 with 3. Out of all these 3 elements, 1 is my smallest element, right? So that is why the smallest rank which is possible for me will be 1. So I will put 1 over here. Okay. Then I will check for 3, or maybe we can check for 2. It is your choice. Okay. So I check for 2. When I'm checking for 2, I know the rank of 2 should be greater than rank of 1, which is 1. And rank of 2 should be less than rank of 4. Okay. Now we don't know what will be the rank of 4. Okay. But I know that rank of 2 should be greater than rank of 1, which is 1. So I can place 2 over here. Then I check for 3. Rank of 3 should be greater than rank of 1, and it should be less than rank of 4. So we can say that it should be greater than 1. Rank of 3 should be greater than 1, and it is not dependent on 2. So we can say its rank is 2. And 4 is greater than 2 also, 4 is greater than 3 also. So it will be 3 over here. That's why we got this answer. Okay. Similarly, we have another example over here. Now we are in this array. Okay. So when we are working with this array, we will have different elements which are dependent on each other. So over here I have 20. See, I'll start from 20. I'll check its entire row and I'll check its entire column. Now 20 is greater than 19 also. 20 is greater than 21 also. Minus 21 also. So now in the same column and in the same row when I am moving, it is not the smallest. So I cannot place anything for it. I'll just not place over here. I'll check for minus 19. Minus 19 is the smallest for this column also and for its row also. So I can place 1 for it. Then see, we had a condition, right, that if P is equal to Q, then rank of P should be equal to rank of Q. So minus 19 will also be 1 over here. Okay. Then I am checking for the next element. For example, if I check for 4 over here. Now I know that 4 is greater than minus 21, minus 47 and minus 19. So rank of 4 should definitely be greater than the rank of these three elements, right? And then the rank of this 4 should be the same as the rank of this 4, since they are lying in the same row and the same column. So these are a few dependencies which we have to work on. So over here, minus 47 is the smallest in its row and its column. So I'll have 1 over here, right? I placed 1 for it. Then if I check for minus 21 is greater than minus 47, but it is smaller than all the rest of the elements which are in the same row and the same column. So it should be greater than 1. So we placed 2 over here. Similarly, when I was checking for 4, now I can place for 4. It is, this one is 2, this one is 1 and this one is also 1. So basically the rank of 4 should be greater than 2 overall. So we place 3 over here and 3 over here. Right? This way we will move in the entire array and we will find our final answer. Okay. So I'll just go back. I'll go back to the open board and I'll show you what I want to say. Okay. So over here, let's say I have a matrix of 5 by 5. So 1, 2, 3, 4, and 5. And 1, 2, 3, 4. Okay, so I have a matrix of 5 by 5 and I need to work on it. And I have a few elements over here. We will discuss all the conditions which we were just reading and we will see what we will use to solve this question. Okay, so I just get okay. Now see, I have a 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5. 5 by 5 matrix. Alright, so let's suppose I have placed 7, 7, 7, 7 and then 7 and 7. Alright, so now first thing which we need to know is that we need to print in increasing order. Okay, so we need to print the ranks. We need to take the ranks in increasing order. Okay, and the elements should be in increasing order. So before I'll place 7, all the elements which are smaller than 7 have already been placed. So that is the condition, that the elements will also be in increasing order, and try to put the ranks in increasing order. Obviously it will happen automatically. Now see, if we are talking about equal elements, so what will happen is that this 7 and this 7 are lying in the same row, right? So if rank of this 7 is x, then the rank of this 7 should also be x. Now this 7 and this 7 are lying in the same column. So the rank of this 7 and this 7 should be x. These two are in the same row, so this should also be x. So these 4 are of equal values, so I can group them together. Now if I want to group things together, what will I use? Union and find, which automatically says that I need to use DSU. Okay, so we understood that we are going to use DSU for this question. Alright then. Now see, for these two, they are not lying in the same row, same column as any other 7, as these 7s. So if the rank of this 7 is y, now y can be greater than, equal to, less than, or equal to x. There's no dependency on each other. Okay. So if the rank of this 7 is y, now these two are in the same row, so it will also have y, and I will group these two together. Okay. So what is happening is, we know that we have smaller elements before 7. All these elements which are smaller than 7 have already been placed. That means the rank x and y, the value of x and y which I will get, will be greater than the ranks of all the other ones, right? So what I need will be that in the row and in the column, I need the maximum rank so far from both the row as well as the column. That means that if I am placing the rank for this 7, all the smaller elements have already been placed. So the rank of this 7 will be 1 greater than the rank of the element which has the maximum rank so far, right? So for example, if I place 6 over here and its rank was, let's say, 2, so the rank of this 7 would be 3. All right. So that is again something you need to take care of. Okay. So we are going to use DSU. We are going to do processing using DSU. So first let us try to code this much, and then we will come back and simultaneously we will keep on coding. Okay. So I make this full screen. And okay, so we have been given a function over here. All right. So the first thing which we will do is, I will get the values of n and m. So let's say n is matrix dot length and m is matrix of 0 dot length. Okay. After that, I need an array for rows as well as columns for being able to maintain all the previous ranks which have been put and all the previous elements which I have already entered. So I will make static int row, let's say row, and I'll create int column. Okay, and then I'm going to resize them. So row will be new int of n into m, and no, it will be only n, right? Over here I need for rows. So yes, rows will be for n, and then column will be new int m. Okay. Now see, the next thing which I need to do is, I need to maintain a record of the element, its row, and its column, right? So I will need a pair class so that I can store these three things. So what I'm going to do is, over here we'll create a class pair. Okay, and in this we have the row, we have the element, and we have the column, and we are going to make the function that is int element, int r, and int c. Okay, where this dot is equal to element, and this dot r is equal to r, and this dot c is equal to c. All right. Okay, so I will create a pair array where I will store all of this. So over here I will create a pair array. Okay, let's say new int. Now for this pair array, I am going to place the element, its corresponding row and column rank, right? So I need to work for all of the cells. So what will be the size? N cross m. Okay. Now see, now the next thing which I am doing is, after I am done with all of this, I need to place, right? I need to place in the array. So I take a variable k as 0. Okay, then for int I equals 0, I is less than n, I plus plus. Then for int j is equal to 0, j is less than m, j plus plus. Okay, I am going to place in the array. So array of k will become new pair. Okay, and in this I am going to place matrix of, let's just take it as mat. Okay, so we won't write a lot. Matrix of I comma j, and then I and j. Okay, so now we are going to work with this, and I am going to increase the value of k by 1, right? All right then. Now this array is of pair type, right? And I want that I have to sort this array. So I'll call arrays dot sort array. But since it is of pair type, then I need to create a comparator also. So I will create public int compare to, over here I have pair b, and I will return this dot element minus b dot le, because I am comparing the elements, right? And here I need to implement implements comparable. So comparable. All right, and the type is pair. Okay, so now we've created our comparator also. Then after that, we are done sorting the array, right? So we need to move in the array. So for int I equals 0, I is less than n cross m, and I plus plus, we are moving in the pair array now. Okay, and I want that I can get the element from this array, from the pair array, and I want to check from the last value. Okay, like just the previous value which I took. So I'm going to take a last value, int last, and first I'll initialize it as integer dot min value. Okay, and then I'm going to get my value, that is int val will be equal to array of I dot le. Okay, and I'm going to check that if val is not equal to last, then in that case, if val will not be equal to last, then I need to process all this data, right? So I'm going to process my data. So I'll create an array list. Okay, over here I will create an array list of the type pair. Okay, and in this array list, see what we will do. New array list. Okay, so what we will process the array list, and also I need to work on the matrix. So instead of working on it separately, I'll just pass the matrix over here only. We will process the array list as well as the matrix together. Okay, and last will become equals to val. Okay, and then al will be newly assigned. I'll get a new array list for the next element. Okay, so over here I will create a new array list. Then I will keep on doing this for all of the elements. I am creating the array list for all of the elements, right? But in the end, I will have to add my last element also. So al dot add array of I, right? I have not added my current element to the array list yet. I was just working with the previous elements till now. So I need to process this as well. So what will I do? I'll exit and I'll process al and mat again. And we need to return the matrix. Our return type is matrix. So we will return matrix. Alright. Now we need to write our process function. Okay, so over here we will write our process function. So we will see how we will do the processing. So we have public void process and we pass an array list to it. Array list of type pair. Okay, let's call it AL, and along with it we are passing our matrix, right? So in this we will work. So I need the length also. So I get matrix dot length and int m is equal to matrix of 0 dot length. What? Okay. Now see, the row, the matrix, the array which we created for row was storing the maximum rank so far in row of I, right? And similarly, the column array was saving the maximum rank so far in column of I, right? So over here, what we will do is we need to work in this. See how over here, when I'm working with these ranks, maybe I get this rank as 3 initially. When I'm working with them, I know they should be equal, but maybe I get this as 3, I get this as 2, I get this as 2, and I get this as 3. I want all of these to be equal, right? So obviously, since this rank is 4, it cannot be less than 4, right? The rank over here cannot be less than 4 since I've placed all the smaller elements earlier only. And if I have this rank as 4, then that means there already exists an element which has rank 3. So what I'll do is all of these elements will now have rank 4 only. So I need to compare, right? I need to compare all of these from my using my pair class, and I will compare all of these and I will update according to that. So over here, what we will do, we will go in a for loop for pair of p in the array list which we are creating, right? And I will take our row and in j will take p dot column. Okay, then I am taking p1. Now see, I need a parent array also, right? I want that my parent array should be the same for the row as well as for the column. So in that case, what can I do? I can divide it in two parts from the middle. This part can be for the row and this part can be for the column. And the size of row array was n, the size of column array was m. So what will be the size of my parent array? N plus m, right? So first I will create my parent array over here. I have int parent array and it will become new int n plus m. Okay. Now I will get p1 and I will create a function called find parent. Okay. So find parent and I will pass I and p1. I will ask I and parent array. Then I need int p2 and I will pass j plus n and parent array. Why did I pass j plus n? Because j is going from 0 to n and I've already placed 1. So I want that also. So I'm placing j plus n. And then if p1 is not equal to p2, then we will put parent of p2 equals to p1. Okay. Now see, there's something which we have missed over here. And that is that we have only initialized parent array, we've declared it, but we have not put any values in it. It still has 0, 0 everywhere. So we need to work with this. Okay. Now see, we need to find out the maximum rank, right? So we need to work with the maximum rank. Now one way of finding the maximum rank from this will be to keep on updating the matrix again and again. Check for here, check all the smaller elements, then check over here, then update. Then go here, check the previous one, check all the ones in the group, then update. Then go over here, check all the ones in the group, then update. Then go over here, check the ones in the group and then update. So it will be a very tedious work to do. Okay, we will have to go in the group again and again and again and again, and I will keep on checking and I will have to keep on updating these values also, and I have to update my matrix as well, right? So I will update the matrix as well, right? Now, either you can do this, that you go to this position, go to a group, find, place an element, and find out which will be the smallest rank from all of these, or maximum rank from all of these. Then check in the row, check in the column, check in the entire group, and then update. And you will have to update this in the row array also and in the column array also, that okay, I have found another maximum rank now, so you have to update your value also. So won't it be a very tedious work to do? Now, I am saying that instead of doing all of this, I will use my parent matrix itself. Okay. So over here, let's say I have my parent matrix, right? I am saying that I will put -1 only in this parent matrix. Okay. I am putting -1 only, and this is initially the maximum rank. Now, for all of the positions, I have a parent. So let's say I am saying that for 2, for 3 I have the parent 2, and for 4 my parent is 3, right? So now for parent of 4 I will get 3, parent of 3 I will get 2. But when it will try to look for parent of 2, then it will get -1. So I'm saying when I'll get -1, no, I'll return I only. So I will return I. So this will give me 2. So over here I'll get 2. From here also I'll return 2. So this will update and become 2. So in the set of 2, 3 and 4, I will be able to find out the maximum rank, right? So basically what I'm doing is I'm using a negative value, because if I will use a positive value in the parent array, then it will make me go to some other place only where I don't want to go. So for example, if my maximum rank, which I need, maximum rank should be 3, then I will make it store -3, so that it does not make me go to any other index or any other position, and I will be able to get my maximum rank as well. But for that I need to figure out the code for my function, which was find parent. Okay, so what we are going to do is we are going to create a function find parent, right? Over here I have public int find parent, and in this we are passing, let's say, an integer u, and we have an integer array parent. Okay, so in this we will check that if parent of u is already negative, if it is already negative, then I will return I only, so I will return u. Okay, otherwise I will return parent of u equals to find parent of u comma parent. All right, so this is how my find parent will work. Then after that, over here I am updating the value of parent of p2, but I need to also update the value of parent of p1, right? I need to update the value of p1 also. So how will I update this? This value needs to be my maximum rank, but I have not figured out what will be my maximum rank yet. So I need to figure out my maximum rank first. So over here I'll create an integer maximum rank. Okay, and what will this maximum rank will be equal to? So I am finding out it in negative, so I want to take the minimum value, right? The rank should be the smallest number possible as well. So over here I will take mat.min, and mat.min of parent of first p1, because something must be there at p1, so parent of p1. Then with this I need to compare parent of p2 also, so I get parent of p2, but I need to find out the minimum from parent of p2 and the rows and columns. So over here I will need math, this is capital M, so this will be math dot minimum of parent of P2, and I need to find out the negative maximum possible from rows and columns, right? So I'm finding the rank from rows as well as the columns array. So I will get the maximum from it, but I want to turn it into negative. So I will get maximum of math dot max of rows of I, okay, and column of row of I and column of j, okay. And along with that, first let me check the brackets. So this bracket I need over here, all right, and along with it I will need -1, right? Why are we doing -1? Because I want a positive value, so I will subtract -1 from it, so I will get a greater value, okay. So I'll just check if I have all the brackets over here. I have the bracket, all right, so the brackets are correct, okay. So now we will work with updating our matrix, and this will become equal to maximum rank. So now finally we are going to update our matrix. So we are going to work in pair P, and we will move along our array list. So first I need to retrieve I and j. So I will be equal to P dot R and j will be equal to P dot C. Okay, and I am going to find from the parent. So find parent, and in this I will pass I comma parent array, okay. Then I need to find my rank, so I'll get the rank from parent of P, but I wanted it to be, since it is the maximum possible and I was making it negative, so I'll write minus over here. I retrieved negative maximum rank from here, but when I need to return it, it should be positive only, no? So I need to do negative over here also, okay. Then matrix of I j will become equal to rank, row of I will become equal to rank, and column of j will become equal to rank. So this will complete the code, okay. So I hope you understood what we were doing over here. Thank you for watching the video. We are still working on the test cases of this question, so it will take a little time, but have faith that the code is it is correct. So please practice it, check it out by yourself also, okay. And thank you for watching the video. We will see each other the next time. Till then, please like, share and subscribe to the channel. Thank you.